So, good morning everyone. I am editing Tulang. So, for today's video, we will discuss the integration using U substitution, the integration by parts, trigonometric substitution, the partial fraction, and the double and triple integral. So, first is the integration using U substitution. So in this topic, our objectives is to be able to learn on how to solve using U substitution. So we have here the formula. We have number 1 is integral of u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c. Number 2 is integral of du over u is equal to ln of u plus c. So number 3 is the integral of e raised to u du is equal to e raised to u plus c. And the integral of a raised to u du is equal to a raised to u over ln a plus c. So we have next is our example. Let's have an example. So example number 1 is the integral of x dx over x plus 6 squared. So let u is our x plus 6. So remember that our u can be found at the inside the parenthesis or in the denominator, or it can be found at the square sign. So du is x dx. So we have to substitute. This is our du and this is our u. So we have integral of du over u is equal to, so remember that the integral of du over u is equal to ln of x plus c. So we have ln of u squared of u squared plus c. So we have to substitute u to x plus 6. So we have ln of x plus 6 squared plus c. So this is the final answer for our example number 1. So next is our example number 2. So we have integral of x plus 1 over square root of x squared plus x minus 3 dx. So let's put it here. Let u is equal to, as I said earlier, our u can be found at the denominator or in the squared sign. So we have x squared plus x minus 3, and the du is 2x plus 1 dx. So we have to add here 2 because our du is 2x plus 1, so we have 2 times x is 2x plus 2 times 1 is 2, and then 1 half. So we have, this is our du and this is our u. So we have 1 half integral of du over u raised to 1 half. 1 half integral of, we have to transpose u, so we have u raised to negative 1 half du. 1 half multiplied by u raised to 1 half over 1 half plus c. So this is 0 now, so we have 1 half so we have u raised to 1 half plus c. So let's substitute the u, that is the x squared plus x minus 3. So we have x squared plus x minus 3 raised to 1 half plus c. Or we can write it as or square root of x squared plus x minus 3 plus c. So this is our final answer for our example number 2. So let's move on to our next topic. So we have our next topic is the integration by parts. So our objectives in this topic is to be able to learn and understand the integration by parts. So we have the formula for integration by parts. We have integral of u dv is equal to uv minus the integral of v du. So let's have an example. Example number 1. Integral of x sin x dx. So let u is equal to x, du is equal to dx, dv is equal to sin x du, and our v is equal to negative cosine x. So we have to substitute. Our u is x and v is negative cosine x, so we have negative x cosine x minus the integral of v du, which is the negative cosine x and dx. Next is equal to negative x cosine x minus, or negative times negative is plus, so we have integral cosine x dx equal to negative x cosine x plus the integral of cosine is sine x dx plus c. So this is the final answer for our example number 1. So next is our example number 2. Example number 2 is the integral of x cosine 4x dx. So in this case, we will use the DI method. So we have using DI method or the differential integral method. So we have, so this is our u, this is our du. Our u is x. Sorry, this is x raised to 3. So we have x raised to 3, and the integral is cosine 4x. So the derivative of x raised to 3 is 3x squared, and the derivative of cosine 4x is sine 4x over 4. Next is this is 6x. 6x. So we have the derivative of sine is negative cosine 4x over 16. We have 6. Derivative of negative cosine is negative sine 4x over 64. And 0, the derivative of 6 is 0. So we have the cosine 4x over 256. So this is positive, negative, positive, negative, positive. So we have the x cubed over 4 sine 4x. This is the positive, negative times negative is positive. So we have 3 over 16 x squared cosine 4x. Here is the positive and negative, so we have negative 6 over 64 x sine 4x. And the last is negative 6 over 256 cosine 4x. So here we will write it the final answer. So we have x raised to 3 over 4 sine 4x plus 3 over 16 x squared cosine 4x minus the 6 over 64 x sine x x sine 4x. So let's continue here. Then we have negative 6 over 256 cosine 4x. So this is our final answer for our example number 2. So let's move to our next topic. So we have our next topic is the trigonometric substitution. So in this topic, our objectives is to be able to learn the different techniques and to learn and solve trigonometric substitution. So here are the 3 cases in trigo. So we have 3 cases. 3 cases in trigonometric substitution. So we have the expression a squared minus x squared and substitution is x is equals to a sine theta. So next expression is a squared plus x squared. So the substitution of this is x is equals to a tangent theta. Next is the x squared minus a squared. So the substitution of this expression is a secant theta. So let's have an example. Example 1. So we have the integral of square root of 4 minus x squared over x squared dx. So remember that this topic. So remember that this case is the case number 1, the a squared minus x squared, that is equal to x is equal to a sine theta. So we have the x, our x is 2 sine theta, and the dx is equal to 2 cosine theta d theta. So we have integral of 4 minus 4 sine theta over 4 sine squared theta multiply by 2 cosine theta d theta. Next is the integral of cosine squared theta d theta over sine 2 theta. So the integral of this is the integral of cotangent squared theta d theta, or so remember that let's recall cosine squared theta plus sine theta is equal to 1. So cotangent squared theta plus 1 is equal to cosecant squared theta. So the cotangent squared theta is equal to cosecant squared theta minus 1. So we have integral of cosecant squared theta minus 1 d theta is equal to negative cotangent theta minus theta, because 1 is minus theta plus c. So this is not yet our final answer. We have to draw the representative. So we have this is theta, this is x, this is 2, and that is 4 minus x squared. So we have integral square root of 4 minus x squared over x squared dx is equal to square root of 4 minus x squared over x minus sine raised to negative 1 x over 2 plus c. So this is the final answer. So our next topic is about the partial fraction. So our objectives in this topic is to learn some techniques on how to solve the partial fraction. So we have the case 1. We will use the case 1. That is the distinct factor. So in the distinct factor, we have the equation. The equation. X minus a, then x minus b, and x plus c. We have a over x minus a plus b over x minus b plus c over x plus c. So let's have an example here. Number 1. We have integral of 5 over x squared 4x minus 12 dx. So we have to factor this. We have to factor, that is x plus 6 and x minus 2 is equal to a over x plus 6 plus b over x minus 2. So we will use the cover up method. So we will write it here using COM or the cover up method. So we have a is equal to, we have to cross multiply this, so we have our a is 5, so we have 5 over x minus 2, and here we will eliminate 6, so we have to add negative 6. X is equals to negative 6. So negative 6 we will substitute to the x. So we have 5 over negative 6 minus 2. So that is equal to 5 over negative 8. So next is the b, that is 5 over x plus 6. So we have to eliminate negative 2, so we will add positive 2. So we have 5 over 2 plus 6 is equal to 5 over 8. So let's put it here, or we will erase here. Okay. I will rewrite it. So using COM or the cover up method. So let's substitute the value of a and b. So we have the value of a is 5 over 8 over x plus 6 dx. I forgot to put the integral sign. Plus the value of b is 5 over 8. Negative 5 over 8 over x minus 2 dx. So we have negative 5 over 8 ln of x plus 6 plus 5 over 8 ln of x minus 2 plus c. So this is the final answer. So let's move to our second example. So next is the example number 2. So we have integral of 10 over x squared minus 9x plus 14 dx. So first is we will factor the denominator. So we have 10 over x. So we have x here minus 2 and minus 7. So we have a over x minus 2 plus b over x minus 7. So using the cover up method, we have a is equal to 10 over x minus 7. X is equal to, we have to eliminate negative 2, so we will add positive 2. So we have 10 over 2 minus 7 is equal to 10 over negative 5. Then b is equal to 10 over x minus 2. Plus 7, we will eliminate positive 7 and negative 7. So we have to add positive 7 is equal to 10 over 7 minus 2. That is equal to 10 over 5. So let's substitute the value of a and b. So we will continue here. We have the integral of a is 10 negative 10 over 5 over x minus 2 plus dx plus the value of b, which is 10 over 5 over x minus 7 dx. So we have to simplify this. So we have negative 2 ln of x minus 2 plus 2 ln of x minus 7 plus c. So this is the final answer for our example number 2. So our next topic is the double and triple integral. So our objectives in this topic is to learn and understand the multiple integrals. So let's have an example. Integral of 0 to 2, integral of 1 to 3, xy squared dy dx. So remember that 1 and 3 is correspond correspond to the two y values. So first is we will solve this. So we have integral of 1 to 3 xy squared dy is equal to xy. We will add here plus 1, so we have 3 over 3. So we will, because we have two variables, we will make y is equal to 1 to y is equal to 3. So we have x over 3, and then y, we will substitute 3 for y. We have 3 raised to 3 minus 1 raised to 3. So we have x over 3, 3 raised to 3 is 27, minus 1 equals to, this is 26, so we have 26 over 3 x. So next is we will find the entire derivative of the x prime. We have 26 over 3 multiplied by x squared over 2, we limit of 0 to 2, so we have equal to 13 over 3, because 26 divided by 2 is 13 over 3 x squared 0 to 2. So we have 13 over 3. We have to substitute 2 to x, so we have 2 raised to 2 minus 0 raised to 2, and equal to 13 over 3. 2 raised to 2 is 4, so we have, and this is 13 times 4 is 52 over 3. So this is the final answer for the double example. This is the double integral. So next is for the triple integral. So example for triple, this is triple integral. So we have integral of 0 to 3, 0 to x, 0 to x minus 4, 4xy, dz, dy, dx. So first is we have to evaluate this. So we have 0 to x minus y, 4xy dz is equal to 4xy multiplied by z. So we will make z at 0 to x minus y. So we have 4xy, x minus y is equal, minus 0 is equal to 4x squared y minus, we will distribute 4xy, so we have 4xy squared dy dx. So this is our evaluation for this. So we have the right, we have 0 to 3, f0 to x, and 4x squared y minus 4x y squared dy dz. Dx. So we will evaluate this. We have f of x 4x squared y minus 4x y squared is equal to 4x squared y squared divided by 2. We will divide it by 2 minus 4xy squared over 3. We'll make y is equal to 0 to y is equal to x. So we have 2x squared, because this is y, we will substitute y to x. So we have x squared minus 4/3 x. We will substitute y to x again, so we have x cubed minus 0. So this is equal to 2x raised to 4 minus 4/3 x raised to 4. So that is equal to 6 over 3 x. We will make 6 over 3 minus 4/3 x raised to 4 is equal to 2/3 x raised to 4. So we'll continue it here. Our last is the integral of 0 to 3 2/3 x raised to 4 dx is equal to 2/3 x raised to 5 over 5, value to 0 to 3. So we have 2 over 15 x raised to 5 0 to 3, and that is equal to 2 over 15 times 3 raised to 5. We will substitute 3 to our x minus 0 for our 0. That is equal to 2 over 15. 3 raised to 5 is 243. So we have the answer of 162 over 5. So this is the final answer for our example in triple integral.